Now, in this video, we're going to take up one more problem. The problem number 3. A solid circular shaft has to transmit a power of 1000 kilonewton at 120 rpm. Find the diameter of the shaft if the shear stress of the material must not exceed 80 Newton per mm square. The maximum torque is 1.25 times of its mean. What percentage of saving in material would be obtained if the shaft is replaced by a hollow one, whose internal diameter is 0.6 times its external diameter? The length, material, and maximum shear stress being same. So this has been asked quite several number of times in the examination. So this will going to be one of the important problems. So first we will going to consider the data. So here he has given capital N as 1000 kilonewton, 1000 kilowatt, and small n as 120 rpm, and tau is 80 Newton per mm square. Then T max will be equal to 1.25 times its T mean. So Di will be equal to 0.6 into D naught. So first we are going to take up the equation since he has given the power. So the power transmitted by the shaft capital N will be equal to 2 pi N into T mean divided by 60,000 kilowatt. So substitute the values of torque, which is 1000, power is 1000, 2 pi into 120 into T mean divided by 60,000. So on simplification, the mean torque T mean will be equal to 79577.5 Newton meter. So convert this into Newton mm will be equal to 79577.5 into 10 to the power of 3 Newton mm. So we know is the given problem, he says the maximum torque is given by 1.25 times the T mean. So substitute the value of T mean and into 1.25, you multiply that. So 1.25 into 79577.5 into 10 to the power of 3. So you will going to get, on simplification, you will going to get it as 99.472 into 10 to the power of 6 Newton mm. Because convert that into Newton, which will be 10 to the power of 6, that is multiply by 10 to the power of, that is divide by 10 to the power of 3. So you will going to get it as 79.5775 into 10 to the power of 6 into 1.25. On simplification, you will going to get it as 99.472 into 10 to the power of 6 Newton mm. So now we know the maximum torque T max, which is equal to T, which is equal to 99.472 into 10 to the power of 6 Newton mm. So first we are going to consider the first case of the solid circular shaft. So design the shaft for maximum torque. So from the torsional equation, based on the strength criterion, T by tau will be equal to T by tau will be equal to Jp by R. So T will be equal to tau into Jp by R, which is equal to tau into Zp. So we know the torque, what is Zp? Pi d cube by 16 into tau, which will be equal to torque. Now substitute the values. Torque we know that is 99.472 into 10 to the power of 6 equals pi by 16 into d cube into tau. Tau we know which is 80. Substitute the values. So on simplification, the diameter of the solid shaft, which is d, will be calculated, which will be equal to 185 mm. Now we will going to consider the hollow circular shaft. So as both shafts being made of same material and transmit the same power with the same speed, which is given in the problem. So Ts will be equal to Th. So we know Ts is pi d cube by 16 into tau will be equal to pi by 16 into d naught to the power of 4 minus di to the power of 4 by d naught into tau. As the material is same, so it will automatically, the shear stress will going to be get cancels, and pi by 16 on both on the left hand side and the right hand side will going to be get cancels. Therefore, d cube will be equal to d naught to the power of 4 minus into 1 minus di by d naught whole to the power of 4 divided by d naught. So we substitute the values of d cube which we have got from the previous value, which is 185, which will be equal to 185 cube will be equal to, so here what happens, d naught to the power of 4 and d naught in the denominator, so it will going to come d naught cube into 1 minus, we know di by d naught will be equal to 0.6, which is given in the problem. So 1 minus d naught cube into 1 minus 0.6 to the power of 4. Therefore, on simplification, the outer diameter of the hollow shaft, which will be equal to d naught, which is 193.76 mm. So inner diameter of the hollow shaft, which is di, will be equal to 0.6 into d naught. So that will be equal to 0.6 into d naught, which is 193.76. On simplification, you will going to get it as 116.26 mm. So now we will want to calculate what is the percentage of saving in material. So what is the material weight is given by volume into weight of the density of the material. So the weight of the hollow shaft, that is WH, will be equal to pi into d naught square minus di square into LH into small wh, that is the specific weight of the material, divided by 4. So percentage of saving in material will be equal to Ws minus WH by Ws. So that is pi d square by 4 into Ls into Ws minus pi by 4 into d naught square minus di square into Lh into Wh, divided the entire thing whole over pi d square by 4 into Ls into Ws into 100. As we know that the length of the solid shaft and the hollow shaft are equal, and specific weight of the materials of both solid and hollow shafts are equal. So therefore, that will going to be removed. Pi by 4, pi by 4 and pi by 4 taking the common factor, that is also removed. D square minus d naught square minus di square by d square into 100. So we know the value of d square, which is 185, substitute, minus d naught is 193.76 square minus 116.2 the square. The entire thing is divided by 185 square into 100. So therefore, the percentage of saving in material will be equal to 29.76 29.76%. So this is how you will be able to calculate the percentage of saving in material. Thank you.